What's happening, guys? Welcome to another episode in the OpenCV Basic series. In this episode, we're going to be focused on edge detection. Now, edge detection is a useful technique which normally forms part of a broader computer vision pipeline. One particular use case where this is actually used quite a fair bit is in automatic number plate detections. Typically, you'd use edge detection before you start taking a look at applying OCR. Nonetheless, let's take a deeper look as to what we'll be going through in this episode. Alrighty guys, so in this episode, we're going to be focused on three key things as per usual. First up, we're going to be taking a look at how we can apply edge detection, and for that, we are going to be using the Canny edge detection algorithm. I'm also going to show you how to tweak it. So if you need to have slightly higher detection thresholds or lower detection thresholds, I'm going to show you how to tune that. And then last but not least, I'm going to show you how to export the edge results that you've actually gone and generated. So if you need to go and share this or put it into a presentation, you definitely can do that. On that note, ready to do it? Let's get to it. Alrighty guys, so in order to go on ahead and perform our edge detection, there's four key things that we need to do. So first up, we need to go on ahead and import our dependencies. Then we're going to go on ahead and load our image, and we can actually load that from our machine. So in this particular case, I've got one image that we're pretty much going to be working throughout all of this. So it's inside of a folder called, let me zoom in, called data, and then images, and then I've got this image here called bike, which we're going to be using. So if I open that up, you can see it's an image of a dude riding a bike out in France, living the life. Okay, so I think it's in France. I don't know, who knows. All right, so we're going to load our image. Then we are actually going to go on ahead and perform our edge detection. And I'm sort of going to show you this with a number of different pre-processing steps applied as well. So we'll perform the raw Canny edge detection, and then we'll go and do some extra stuff. And then last but not least, we're going to export our edges, and we're going to do that just using the cv2.imwrite method. But before we dive into this, let's actually take a look at how this is all going to work. So first up, we're going to grab an image, then load it into Python using OpenCV. This will give us a representation of that image as a NumPy array. We can then apply a number of pre-processing steps before applying the final edge detection algorithm. What does this look like exactly? First up, we use OpenCV's imread method to load the image into Python. Then we'll use the cvtcolor method to convert that image to grayscale. Then apply a Gaussian blur to reduce the image's noise. This improves the edge detection's final end result and is actually recommended in the documentation. Finally, we're going to use the Canny edge detection algorithm to find edges. This will give us our end result, which allows us to find edges in images. Let's get back to it. And we're back. Okay, so first things first, let's go on ahead and import our dependencies. So in order to do that, I'm going to import two key dependencies. These are OpenCV and the OS library. So OpenCV is going to give us all of our computer vision stuff. The OS library is going to give us some operating system libraries to basically make it easier to navigate through different file and folder structures. So let's go on ahead and import this stuff. Okay, so those are our two libraries now imported. So I've gone and written two lines of code there. So the first one is import CV2. So this is going to allow us to work and perform some computer vision with our computer vision libraries. And the second one is import OS. So this is going to give us our operating system library and allow us to work or build up different file paths. Okay, so now that that's imported, the next thing that we can actually go on ahead and do is load up our image. Now, this is relatively straightforward. We just need to define a file path to our image and then actually go on ahead and load it up using cv2.imread. So first things first, let's go on ahead and create a file path. Okay, so that is the path to my image. So data, images, bike. Let me actually show you this. So if I go into the folder that I'm currently working in, OpenCV, so my image is actually inside a folder called data and then images, and then I've got this image here called bike. So if I actually go and take a look at that image and go to properties, you can see it's called bike.jpg. So if we want to load that into OpenCV, we need to pass through the full file path to that particular image, which is going to be data, images, and then bike.jpg. This is exactly what we've gone and defined using the OS library. So this is going to be the file path to the image. So I've gone and created a new variable called image path, and then I've So it's basically image in all caps, so image underscore path, and then I've set that equal to os.path.join. And then to that, we've gone and passed through the full file path to that specific image. So in this particular case, I've gone and passed through data and then comma, images, comma, and then bike.jpg. Now what I can go on ahead and do is actually load this into OpenCV using the cv2.imread method. So let's do that. Okay, so that is our image now read into Python. So if we actually go and take a look at this now, so if I type in image, you can see that this is a set of all of our image values. Now, if we actually wanted to go on ahead and visualize this, we can actually do that. Now, we can use OpenCV, but it is a bit of a pain because we need to go and resize stuff. So we can actually import matplotlib. So I can type in from matplotlib. Okay. So in order to import matplotlib, I've written from matplotlib import pyplot as plt. So this just makes it easier to visualize our image. Now we can actually visualize our image using OpenCV as well, but it just requires a bunch of additional lines of code. Plus you need to resize your image. So if we just go and use this, it just makes life a little bit easier. So if we want to actually see what this image is, we can type in plot.imshow. And then pass through our image, and this is actually going to allow us to visualize our image there. So you can see that's our image of our dude. Now, if we wanted to go and change our color, we can type in, so you can see right now it's a little bit blue, right? You know what? I wonder if using the OpenCV visualization is going to be better because this is a bit small. Let's do it. All right. It's a bit of a pain, but I'll show you how to do it. Okay, so we can type in, let's actually make this a function. Is it going to work? Let's not wrap it in a function. Okay, so if we go and first up, what we want to do is let's just do a baseline viz. So let's visualize it using OpenCV. So view image using OpenCV. Okay, so that is our image now visualized with OpenCV. So I've gone and written 3 different lines of code there. So first up, cv2.imshow, and then to that, I've passed through what I want the frame to be called, and then I've gone and passed through the image itself. Then I've written cv2.waitKey, so this waits to see whether or not we hit a key on our keyboard. And what you'll see is that if I open this now, and if I hit any key, literally any key on my keyboard, it's going to close down that frame. So let me go and run it again. You can see that's our image. I can hit letter P, it's going to close it down. Run it again, hit space, it's going to close it down. All right, so that is what that does. And basically that's waiting for a key to be hit. And then if that key is hit, it's going to run the last line of code, which is cv2.destroy all windows, which actually shuts it all down. So if I go and run this again, that is our image. But right now you can see that it's way too big to actually see the full image in its entirety. So what we can do is we can actually resize this image before we go and pass it to our cv2.imshow method. So let's go on ahead and add this last line of code so we can actually see it fully. Okay, that is our image now resized. So I've gone and probably written 2 additional lines of code there, or written 1 new line of code and updated 1 line of code. So you can see that we can now see our image in its entirety within our frame, right? A little bit easier to actually visualize there. So this is the main line of code that I went and wrote, and then I also went and updated a parameter inside of cv2.imshow. So let me break this down. So I went and created a new variable called resize_image, and I set that equal to cv2.resize. And then to that method, I passed through the image, or the original image that we had. And then I basically said how big I want the image to be. And for that parameter, we actually need to pass through a tuple. So this is what I passed through. So 1095 and then 1369. So this is going to be our new width and our new height. Now I've automatically gone and calculated those as the original dimensions divided by 2. So in order to do that, I've written image.shape. And so this is grabbing effectively our width. So if I show you that, let's take a look at image.shape originally. So image.shape. So this is going to be our height by our width and then our number of channels. So down here, I'm grabbing this first value here. So image.shape 1, and I'm dividing that by 2, which gives me that value. And then it needs to be an integer. So I'm just passing through
int to cast it into 1095. So that is that value right there. And then I'm doing the exact same thing for the height, but in order to do that, I just need to pass through a different key, which gives me 139, and then I'm wrapping it inside of a set of parentheses, which gives me 1095 by 1369. So this means that if ever we wanted to go and resize our image, we just need to pass it through this line of code here. And if we wanted it to be a third, we can just change this divisor, and you can see that it's way smaller now. Again, we're going to leave it as 2. 2 and 2 down here. Cool. So you can see our image there, or the majority of our image. Now we can delete this and this. Okay, so you can now see that we're able to load in our image and we can actually view it. Now we're up to our edge detection. So let's go on ahead and apply our raw edge detection. Now I'm going to link to this paper or this documentation in the description below. This actually explains in a little bit more detail as to how it works. Now, without going into too much detail, just all you need to know is that we are looking for 2 thresholds. So the 2 key things that we need to pass through to our Canny edge detection algorithm are a minimum threshold and a maximum threshold. And this is based on the gradient of our specific edges. So it actually goes and calculates the gradient, and we're going to specify a lower threshold and an upper threshold. And this determines how many edges we're actually going to get back. So the tighter the threshold, the less number of edges. The wider the threshold, the more number of edges. But for now, let's just go and see how this actually works. So we're actually going to go on ahead and apply our Canny edge detection algorithm now. Okay, so that is our Canny edge detection now applied. So in order to do that, I've written Canny equals CV2 and then Canny. So this is going to be our Canny edge detection algorithm. And then I'm passing through my image and then my lower threshold and my upper threshold. So these are these parameters here. So the minimum value and the maximum value. And again, I'll link to this in the description so you can actually see how this actually works. But for now, just know that a wider threshold is going to give you more edges, a lower or tighter threshold, and a specifically sliding threshold is going to give you less specific edges. So what's the full line? So Canny equals CV2.Canny, and then we're passing through our image, and then threshold 1 equals 180, and threshold 2 equals 200. Now, if we go and use our same visualization code, so if we copy this, paste it down here, and this time what we're going to do is we're just going to sub out and pass through the word, pass through our Canny variable here. So if we go and visualize this, that is our Canny edge detection now visualized. So you can see that we've got all of our different edges now appearing. So it's actually pulling out this P, which is from our parking sign. You can see that we're getting our cars and we're getting the bike. But it is a little bit, we've got quite a fair bit of noise, right? So you can see all these random little dots. Now, what we can also try to do is tighten this threshold. So let's say we set it to 200 to 210. So again, we're still getting edges, still a lot of noise. What happens if we just set it to 205, 210? Again, still a ton of noise. Now, one way that we can start to reduce this noise is by applying a blur function. So if you actually take a look inside of the documentation, what is actually recommended is over here. Since edge detection is susceptible to noise in the image, the first step is to remove the noise in that image using a 5x5 Gaussian filter. We've already seen this in previous chapters. Let's go on ahead and try this out. So we can actually go and apply a blur function or Gaussian blur to actually improve this. So, because right now you saw that there was a lot of noise, all those little dots. So we can actually try applying a blur first. So we are going to create a new variable called blur and apply a Gaussian blur. So I'll walk you through this. Okay, that is our blur now applied. So I've gone and written blur equals cv2.Gaussian blur. And then to that, what I'm doing is I'm passing through my original image, which we had from up here. I'm then going and specifying my kernel size. So this is the region about which we actually go and apply our blur or apply the actual blur. This last parameter is sigma x. Now, I haven't read into this into too much detail. So again, I'll link some documentation as to what that actually means down below after I've read through it as well. So you can see what it actually represents. So we've gone and applied our blur, and then what I'm doing is I'm grabbing that blur variable and I'm passing it through to our Canny method down here. So ideally, if we go and now run our resize again, you can see we've gone and cleaned up a ton of that noise, right? So before we had all of these random little dots everywhere, and you could see that it was definitely detecting edges, but it was all over the shop. So we can actually see that it's a lot cleaner now. Let's just go back so I can show you the raw version. So I'm just going to change the input into Canny back to image. You can see ton of noise. We go and apply our blur. A lot cleaner. So you can see that that is way, way, way cleaner now. So rather than having a ton of blur, we are way cleaner. We could also go and try changing this kernel size. So if we set it to 3.3, let's see what that actually represents. We got to close this down first. Okay, so it's still working pretty well. We could also try changing this threshold. So I think I had at 180, 200. That looked pretty good. No, so that's still pretty noisy there. But I mean, you can see that we're definitely pulling out a ton of edges. So let's go and set our kernel back up to 5.5. Still way cleaner than what we had originally. We could also try grayscaling the image. So let's apply grayscale. So cv2.gray. So cv2.cvt color. And then pass through our image, and then we can convert it to gray by changing the color mode. So I'm going to type in cv2.color and then underscore bgr to gray. And then if we go and pass gray to our blur and then blur to our canny, let's see what this looks like now. So way cleaner. So that, I think actually passing it through the grayscaling applies or cleans it up a ton. So you can see that we don't have a lot of these little random dots anymore now that our edge detection is a lot cleaner, a lot clearer. So let me show you before the grayscaling and then without the grayscaling. So this is you can actually visualize the grayscale. So if we go to our visualization code and change this to gray, that is our grayscaled image. And then if we take a look at our blur, let me just run it again. So this is going to be gray into here. So this is with our blur applied. I don't know if you can see a ton of difference, but there is definitely some blur applied to that. And then if we go and take a look at our canny, this is the final end result. So you can see that by grayscaling it and then applying our blur and then applying our canny edge detection, we've significantly improved our performance. So this, you can actually very clearly see the edges of our sign. We can see our bike. You can even see down the bottom there that we're actually able to see part of the plate. We scroll up. Let me zoom out of that. We scroll in. We can see, I've gone and closed that now. You can see that we can see the parking sign. We can even see some of the labels for the sign there. So it's got 8 to 8 effectively. And then 9 to 5. So you can see that is effectively how to actually go on ahead and perform your canny edge detection. So we can actually do stuff with this now. Now, normally you'd take this and you'd pass it through to our next pipeline, maybe apply some dilation or erosion to actually go and apply some AMPR. We'll probably cover that in a future tutorial. But you can definitely see that those are our edges now successfully extracted. So the last thing that I wanted to show you is how to export this. So if you wanted to go on ahead and save your image, you can use the cv2.imwrite method. And we can pass through the name of our file. So we're going to call it edges.jpg. And then we can pass through the name of our image, which in this particular case is going to be canny. And then we can actually go into the same folder that we're currently working in, which is going to be OpenCV. And I've got this file here called edges. If we zoom in, you can now see the result of our edge detection. So we've got our street signs there. We've got the shape of our car. We've got our number plates. We've got part of a person. So again, you could play around with that or play around with the different parameters to see if you could get better results. Let me know what you end up choosing. But that in a nutshell is how to actually go on about and apply edge detection. So we did a ton of stuff in this tutorial. So we imported our dependencies, we went and loaded up our image, and then we went and applied our edge detection. And you sort of saw that by applying different pre-processing steps, we were able to improve our result and get rid of a lot of that noise. So originally, we started off with just the canny algorithm. Then we went and applied our blur. Then we went and applied grayscaling, and that effectively improved our results significantly just by doing those pre-processing steps. But on that note, that about does wrap it up.
Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a big thumbs up, hit subscribe, and tick that bell, and let me know what you're thinking of this tutorial basics series. So I am doing these to allow you to sort of build up some skills which help you along your journey in data science, deep learning, machine learning. That being said, I am getting ready to do some significantly bigger projects. You might have started to see a couple on the channel, but I do have some big things when it comes to machine learning, deep learning, and data science. So do stay tuned for that. But as always, let me know what you thought of this, whether or not you liked it, whether or not you didn't. I'd love to hear your feedback. But nonetheless, thanks again for tuning in, guys. Peace.